We're going to do section 3-3 on this video, or at least start it. But first example, what we're doing is we're talking angular velocity, linear speeds, and the first thing we're doing is just taking one unit of angular velocity and turning it into another. So revs per minute, or revolutions per minute, converting to radians per minute. So in all of these, what we end up doing is we write out our known, sorry, let me call thinner, 8 revolutions in a minute. We need to convert it using some factor so that we get radians per minute. So we want to leave minutes alone. We're not going to convert minutes to seconds or hours. But one revolution around the circle, we know one revolution of a circle. What we've been talking about in radians, in terms of radians, we said, if you go from 0 and then go all the way around the circle, make a complete loop, we've gone 2 pi radians around the circle. So every time you go around a unit circle, we've gone 2 pi radians about the circle. So that means our revolution units cancel, and we get radians per minute. So we take 8 times 2 times pi, we get 16 pi radians per minute, because our denominators are both 1. Let's see, in this case, number 2, or part B, now we actually get to convert to linear speeds, miles per hour. So instead of just saying how fast are we going around the circle, maybe we're able to do 8 revolutions per minute. That doesn't mean a lot, because if our circle is really small, right? If we're able to do 8 revolutions in a minute, but our revolution is really, really small, that's not really fast in terms of miles per hour. If we were going around a track or a merry-go-round that was this big around, our miles per hour are much different, because 8 times around this circle in a minute doesn't take a lot of speed in miles per hour, whereas trying to hit this circle and go around 8 times in a minute, your miles per hour is going to go up. Okay, so if we're going to do that, we need to say we have to account for the fact that we're doing 8 revolutions per minute. But then we need to know how many feet is a revolution, which that's asking what is the circumference of our circle, or what is the circumference of our revolution. And that is just the equation for the diameter, or excuse me, the circumference of this merry-go-round. So at a 12 foot from the center, that means it's the radius, so 2 pi r, and that's feet. So 24 pi, or about 37 feet, is how many feet it takes to walk around the merry-go-round. So now what we have is we've reduced our revolution units. So now we have feet per minute, which is linear speed. We can travel this many feet in a minute. Unfortunately, that's not the units we need to end in. That's miles and hours. So we still need to keep going. And at this point, it doesn't matter whether we convert feet or the minutes. So we'll just convert our minutes first. So we have to have our minutes on top of our conversion factor so that the minutes cancel. But that's 60 minutes in an hour. Yep, it always goes back to the thick pen. Okay, so now we have hours on bottom, which is good because we want miles per hour. But we still have feet, so now we have feet per hour. We need one more conversion, and that says that 1 mile is 5,280 feet. So the feet numerator, feet denominator cancel, and we get our miles per hour. What we have to do is take 8 times 2 times 60 times pi, take all those numbers on top, multiply them, and then divide that by whatever these are multiplied together, which happens to just be 5,280. So if you take all the numbers on top, divided by 5,280, let me find what that is. That is, how did I lose the pen? There we go. That is 6.85 miles per hour. The only difference between B and C here is going to be that our equation stays the same. 8 rev in a minute. The difference is our 2 pi r changes because now we have a horse that is 4 feet from the center. Okay, and that's per rev. But we still have 60 minutes to get to our hour. We still have a mile conversion from feet. So what's interesting is if that didn't change, that didn't change, that didn't change. The only thing that changed is we went from 12 to 4. Then if our numerator was reduced by dividing by 3, so 12 divided by 3 is 4, that means that our answer, 6.85, should be divided by 3 also. So if you do that, if you run these numbers, 8 times 2 times 4 times 60 times pi, if you take that divided by 5,280, what you'll find is it should be exactly a third of this. The answer is 2.28. All right, so that is example 1. We look at example 2. Example 2 is just taking that information and applying it in different situations. So rather than a big merry-go-round, we just have a bicycle wheel. We have our information. We want to know the RPMs for the wheel. So in this case, let's see, I'll put that back. We went 25 minutes. Oh, let's do it this way. Miles per minute, and we need to know revs per minute. So our minutes are okay. The approximate RPM, we don't need to mess with minutes per se, but we do need to know revolutions per minute rather than miles per minute. So the first thing we have to account is, well, we need one revolution itself. One revolution of the bicycle is a circumference of the bike tire or wheel. And what we know is the diameter is 30 inches. So one revolution is 30 pi inches, right? Because it's pi times diameter. So at this point, we've gotten revolutions to the top. We have minutes in the bottom. The problem is we have miles and inches, and we need to get rid of both of those. So we need 2 conversion factors. Doesn't matter the order, but one of them we're going to get rid of miles, and that's 5,280 feet in a mile. So, okay, we got miles eliminated. Now we have feet in inches, so let's try and get rid of that. So 12 inches in a foot. Look at that. Our foot units cancel, our inch units cancel. One factor got rid of both of those, leaving us with revs per min. So in that regard, we now have, we just have to simplify. So the 5,280 times 12 times 10, divide that by our 25 times 30 pi, and we do this, and 1 point there. That equals, that is 268.9 RPM. There you go.